Hello calculus students, this is Mr. McAllen and this is a recap of what we did today in class and this October 2nd, 2015 and we were working on lesson 2.2, the second part, uh, infinite limits, not limits at infinity but infinite limits. So we started off the lesson talking about a problem from last night where we want to find out what is a horizontal asymptote for this function by considering end behavior. So what we talked about in class as our warm-up was to look at the dominating terms in the polynomial only, because as x goes to infinity for a horizontal asymptote, we're only concerned with, in a rational function, the numerator leading term over the denominator leading term, and because these two values cancel, our asymptote is going to go to y equals 3 over 2. So we did that real quick as a warm-up just to check on how we understood things from last night, and then we got into today's lesson. Our objectives were to use limits to define vertical asymptotes and to practice problems at the whiteboard that ask us to do everything regarding limits. So the first thing we worked on in class was we reminded people that from pre-calc last year, we had different things to do with a rational function. For instance, if we wanted to find the zero of the rational function, we would set the numerator equal to 0, and in this case, there is no 0. We would then find the vertical asymptotes by setting the denominator equal to 0. And in that case, we'd be solving the problem 4 minus x squared is equal to 0. We would have x squared equals 4. Two vertical asymptotes we found at plus or minus 2. And then we would also look for the same graph. We would be identifying a y-intercept, which is found when you plug x equals 0 into the equation. So as a result, we got this graph of our rational function. We had everybody draw it in class, and they all did a nice job of it. So we had an asymptote at positive 2, vertical. So you want to label that as x equals positive 2. We had a vertical asymptote at x equals negative 2. We had a y-intercept at 0, 2. So we had 0, 2. We had a y-intercept, and then when the students graphed the function by using test points, they noticed that they had a horizontal asymptote, and basically the function did something like this. Through the use of test points. Now the point of the lesson was to discuss what the vertical asymptotes are in terms of a limit statement. So we have for every vertical asymptote, we have two limit statements. So for the vertical asymptote, for the limit statement on the left of this asymptote, we would say the limit as x approaches negative 2, because we're on the left-hand side of that negative 2, we're going to put a negative there, of the function is equal to negative infinity, because the function is heading towards negative infinity. When we look on the right-hand side of that asymptote, we would have another limit, and that would be the limit as x approaches negative 2, but from the right of f of x, that function heads up north towards infinity. When we look at, I'm just going to highlight this asymptote, the asymptote we're working on now. When we look at this asymptote, and we look at the direction from the left, we would write up that limit as a limit as x approaches. Now remember, we're approaching from the left, so we're approaching 2 from the left, that's what that little negative sign means, of f of x will equal, because it's going off to positive infinity, we're going to put plus infinity. And the last asymptote, or the last, I'm sorry, limit description would be on this side, and that would be the limit as x approaches 2 from the right of f of x. That heads to negative infinity. So we did all these exercises in class. We talked about these limits, and we tried to categorize, or not categorize, but we tried to describe these asymptotes with two limit statements. And we marched ahead, and we worked with a whiteboard activity where the students had to interpret all these limit statements and construct a possible function that could match that description. So I'm going to just draw an XY axis, and let's get started on drawing this. So hopefully you can understand how we kind of piece this together. So I'm just going to use I'm going to first consider, because I always like to consider my horizontal asymptote. So I'm looking for as x goes to infinity. So that's one horizontal asymptote, and I have another one as x goes to negative infinity. So I'm going to draw both of those. So as x goes to infinity, I have an asymptote at -1. So my function is going to head to -1. And as x goes to negative infinity, I'm going to head to 0. So I have another horizontal asymptote at y equals 0. So y equals -1. In between, I have these two half limits describe a vertical asymptote. So I'm going to mark out to 5. I'm going to mark out my vertical asymptote at x equals 5. And I'm going to know that from the left side of 5, I'm going to head off to infinity. And from the right side of 5, I'm going to head off to infinity. So I have two graphs that look like that. And then I have another asymptote at -2. So I'm going to go to -2. I'm going to draw my asymptote. And I'm going to put in those two scenarios. As I approach -2 from the right, I'm going to negative infinity. So I'm heading that way. And as I approach -2 from the left, I'm going off to positive infinity. So now I just need to fill in one more blank. What do I do with my limit as x goes to 1? It says as x goes to 1, the limit is equal to 2. So it means that I'm passing through that point. So I need to kind of fix my, I need to fix this. So I'm coming through, I'm going to go through that point and up that way. Let me do that again. So that's obeying all those limit properties. And then the rest of it is just filling in. I've got to show how this heads to, as x goes to negative infinity, as x goes to negative infinity, my function is going to go to 0, so I want to do that. And as x goes to positive infinity, my function goes down, to -1 and tries to approach that value. So this should be an acceptable graph of all these restrictions for all of my limits. I hope this video helps you understand what we did in class today. And remember, this was a recap, so I look forward to hearing your comments and suggestions. Thanks.